All right, let's take a look at multiplication of exponential expressions. Remember that when you are multiplying exponential expressions that have the same base, you can add your exponents. All right, so remember that is for when you are multiplying. It is a shortcut, right? We went through why that is the case in this chart here. It is a shortcut for simplifying when you're multiplying. You can add your exponents. Okay, so refer back to your chart when you need to. All right, so we have w to the negative 2 multiplied to w to the negative 6. All right, so we can simplify this expression by adding our exponents. So we're saying w to the power of negative 2 plus negative 6, and that gives us w to the power of negative 8. Now in our directions, it does say write your answer without using a negative exponent. So now that we have w to the negative 8, we'll finish by taking the reciprocal to get 1 over w to the 8th power. And now we are fully simplified, and there's our answer. All right, let's try another one. 2v to the negative 7 times 6w cubed v times 8w to the negative 3rd, x to the 7th, x to the negative 9. Okay, even though we have some places where we put a dot to explicitly say multiplication, each of these factors are multiplied, right? 2 is being multiplied, and then to the v, negative 7 being multiplied. So I could write this as 2 times v to the negative 7 times 6 times w cubed times v times 8 times w to the negative 3 times x to the 7th times x to the negative 9. Okay, I could write it that way. It's not necessary, but I'm emphasizing all of this is multiplication. And remember, the order in which you multiply can be rearranged. And that is to our benefit, because I want to multiply my coefficients here. I want to multiply those first. 2 times 6 times 8, right? I'm going to multiply that as a group. And then everything that has a v, I'm going to multiply that as a group. And then everything that has a w, I'm going to multiply that as a group. And then everything that has an x, I'm going to multiply that as a group. Because I can simplify that. And so 2 times 6 times 8 gives us 96. Now v to the negative 7 multiplied to v to the first power. Add your exponent, so we have v to the negative 6. W cubed times w to the negative 3. Add your exponent, so we have w to the 0 power. X to the 7 times x to the negative 9. Add your exponent, so we have x to the negative 2. All right, we're not done. There's a couple things that we want to fix. One, any factor that has a negative exponent, we want to take the reciprocal. And then also w to the 0 is equal to 1. Right, so essentially we would do 96 times 1, and that gives us 96. And the reciprocal of v to the negative 6, which gives us v to the 6 in the denominator, and x to the negative 2 gives us x squared in the denominator. All right, pause the video and try this question that's on the right here, and then we'll do it together. All right, so you have 2x to the negative 1 times 8u cubed, u squared, x, w to the 7th times 6w to the negative 5th. So again, you can do the order of your multiplication in a different, more convenient order. So I'm going to multiply the 2 times the 8 times the 6 first, which gives you 96. And then all of the x's, x to the negative 1 and x. So you add your exponents, x to the negative 1. X implies an exponent of 1. So that's x to the 0. All right, our u's, we have u cubed and u squared. So that's u to the 5th power. And our w's, w to the 7th and w to the negative 5. Add your exponent, so that's w squared. Okay, you want to simplify this further. The x to the 0 equals 1. So 96 times 1 is 96. And just bring down the u to the 5th and w squared. We don't need to do anything further with them because the exponents are positive. All right. Let's do some work with our quotient rule. So remember, when we have a quotient, when we are dividing, we can subtract our exponents. All right, so if we look here, we have x to the 9th divided by x to the negative 4. See, there's our quotient because we're dividing. And so this is saying that this is equivalent to saying x to the 9 minus the negative 4. All right, so I'm going to convert this subtraction to addition. Some of you might recall keep, change, switch. I like to refer to that. Keep, change, switch. So essentially what that means is I can convert this subtraction problem to addition or vice versa. So x to the 9 we keep, change the minus to plus, and switch the negative 4 to positive 4. Okay, so then that gives me x to the 13th power. All right, I'll be honest. I don't really like the quotient rule. It's necessary, but I just don't like it. It's just my preference. So sometimes when I have a problem like this, instead of using the quotient rule, I'll use what I know about taking the reciprocal of exponential expressions. So I'm going to start this problem again. And so I have x to the 9th divided by x to the negative 4. And I am going to take the reciprocal of x to the negative 4. So that gives me x to the 9th times x to the 4th. Notice how my negative 4 went to a positive 4 when I took the reciprocal. So now at this point, I have a product. I like that. And since I have a product, I'm going to add my exponents. X to the 9 plus 4. And that gives me x to the 13th power. And there you go. So you can do it both ways, whatever you're comfortable with, using the quotient rule or changing your quotient to a product and using the product rule. All right, so here we have a much longer one. We have a to the negative 7, b to the negative 4, c to the 9, divided by a to the 8, b squared, c to the negative 1. Okay, so strictly using the quotient rule, that would mean we would get a to the negative 7 minus 8 times b to the negative 4 minus 2 times c to the 9th minus negative 1. Okay, so this simplifies to, right? If I use my keep change switch, I would have a to the negative 7 plus negative 8. B to the negative 4 plus negative 2. And then C to the 9 plus 1. All right, so that simplifies to A to the negative 15, B to the negative 6, and then C to the 10th. Okay, so now we know that we have to write our answer without using negative exponents. All right, so I'm going to take the reciprocal of a to the negative 15 and b to the negative 6. All right, so that's going to give me c to the 10th divided by a to the 15, b to the 6th. Okay, now as before, I shared my dislike for the quotient rule. So I'm going to try this question again, and this time I'm going to show you how I'm going to do it without using the quotient rule. So I'm going to start the question again. I'm going to take the reciprocal of a to the negative 7. I'm going to take the reciprocal of b to the negative 4, and I'm going to take the reciprocal of c to the negative 1. So in my numerator right now, c to the 9th is going to remain unchanged. In the denominator, a to the 8th and b squared is going to remain unchanged. But a to the negative 7 that was in the numerator is now a to the 7th in the denominator. B to the negative 4 that was in the numerator is now b to the 4th in the denominator. And then c to the negative 1 in the denominator is now c to the 1st power in the numerator. And now I like this. I could just use my product rule. C to the 1st times c to the 9th. We would do c to the 1 plus 9, which gives us c to the 10th. And then a to the 7 times a to the 8. A to the 7 plus 8, which gives us a to the 15th. And then we have b to the 2nd plus 4. So we have b to the 6th. And as you can see, you get the same answer, going a slightly different route. Okay, why don't you try one? So we have here a to the negative 7, b to the negative 1, c to the negative 4, divided by a cubed, b to the 5th, c to the 9th. Pause the video, try this on your own, and then we will do it together. All right, so as always, I am going to do this 2 ways. And so I'm going to start with just strictly doing the quotient rule. Despite that I abhor the quotient rule, but sometimes it's just necessary. Other times it's just good practice to be familiar with different ways of doing things. So here, a to the negative 7 minus 3, and then multiply to b to the negative 1 minus 5, and c to the negative 4 minus 9. All right, you might be wondering, when the order in which I'm subtracting assumes that these terms are in the numerator, okay? So now you use your keep change switch. I just like to use this to change my subtraction to addition. If you use that, we have a to the negative 7 plus negative 3, b to the negative 1 plus negative 5, and then c to the negative 4 plus negative 9. Okay, so that gives me a to the negative 10, b to the negative 6, c to the negative 13. Okay, we have all negative exponents, but we need to take the reciprocal of this entire expression. So that's going to give us 1 over a to the 10th, b to the 6th, and c to the 13th power. Done. Okay, let's rewind that. And we're going to do this again from the beginning, but this time I'm going to start by taking the reciprocal. So this is going to equal, I'm going to put my a cubed, b to the 5th, c to the 9th already in the denominator. And I'm taking the reciprocal of the three factors already in the numerator. So a to the 7th in the denominator, b to the 1st, I'll put that at the end here, and c to the 4th. So there's an assumed coefficient of 1. We don't have to write 1 when we have a variable there, but since everything went to the denominator, we have to put that assumed 1 in the numerator. Okay, let's simplify this by adding our exponents. So we have essentially what we will be doing is a to the 7 plus 3, b to the 5 plus 1, and then c to the 9 plus 4, which equals 1 over a to the 10th, b to the 6th, c to the 13th. All right, so you go with whichever way is most beneficial and easiest to understand for you.